Okay guys, here is the next section, which is 13.2. So hopefully everyone enjoyed my wonderful 13.1. So at least it was the right way, so I'm excited about that. 13.2, so this is once again, we're still dealing with sequences and series, but this is a specific sequence and series. It's called arithmetic. So an arithmetic has a certain definition we need to know, and then we need to be able to do things with it. So unlike last time, we're going to be looking at very specific sets of numbers. Again, this one's called arithmetic. The next one is called geometric. So definition of an arithmetic sequence is a sequence of numbers that have a common pattern. That pattern is adding or subtracting a common number. So it's a sequence of numbers that have a common pattern, and that pattern is adding or subtracting a common number. That common number is going to have a special name. That common number is called the common difference. And we're going to denote it by variable d. D is going to be the common difference. Let's look at a couple examples. Easy one to start. 1, 3, 5, 7. The common difference of this problem would be 2 because we're adding 2 every time. 1, -1, -3, -5, ... Still arithmetic. The common difference this time is -2 because we're subtracting 2 every time. So the common difference can be positive or negative. There's going to be 2 ways that we're going to talk about these sequences. We're going to talk about them in 2 different formulas. The first one is called a recursive formula, and the second one is called an explicit formula. So the recursive formula, let's define what that is. Recursive formula is where we define the sequence using the previous term. So we find one term by using the previous term. This is kind of intuitively how we think about it. There's actually a formula we need for this. So the formula is a sub n equals a sub n minus 1 plus d. A sub n is the nth term. A sub n minus 1 is the previous term. D is the common difference. And the little bit of weird part about an explicit formula is you have to say where it starts. So you always include what a sub 1 equals, whatever number it is. You always need to give it a starting point, because think about it. If we don't know where it starts, we can't find the second term. If we can't find the second term, we can't find the third term. So whenever you do a recursive formula, you always include the first term, always. The second formula we need to know is something called an explicit formula, the explicit formula. The explicit formula means that we can find any term of a sequence. We can find any term. We can find any a sub n as long as we know the n value. So we define the term in terms of what number it is in its place. Once again, it has a formula. A sub n equals a sub 1 plus parentheses n minus 1 times d. Again, let's talk about what all this means. This is the nth term. This is the first term. This is the number of the term. That's that subscript. And of course, this is the common difference. The cool part about the explicit formula is you don't need the previous term. All you need is the first term and the number of the term. This is really cool. So if you wanted to find the 100th term, if you use the recursive formula, you would have to find the 99th and the 98th and the 97th. If you want to use the explicit, all you need is the first term. All right, so it's a little bit easier. Let's do a couple examples. we're going to find the 41st term of the following sequence. I'm going to use the explicit. Again, because if I use the recursive, I'd have to find the 40th and then the 39th, and it would be I'd actually have to calculate this out. This would be a real big pain in the rear end. All right, so here's what my formula says. My formula says that a sub n should equal a sub 1 plus n minus 1 times d. 41st term, I don't know what that is. I want to find the 41st term. I don't know what that is. I do know what the first term is, though, 2. I do know what number it is, right? 41 minus 1 becomes 40. And I do know the common difference. The common difference for this problem is 4. So given that I know all that information, I can quickly find the term I want, right? Because I want to find the 41st term. This becomes 2 plus 40 times 4, which becomes 162. So this means if we did this, if you did it 41 times, I promise you, that number would be 162. You don't believe me? No big deal. Go do it on your own. Do it 41 times. It'll be the same number. I promise you. All right. A little bit more complicated problem if they want us to find the recursive formula, especially for this problem. I actually picked this problem in particular because it's a little bit tricky. Look what they're giving us. They're telling us that the 8th term is 75 and the 20th term is 39, and that's it. And from those two pieces of information, they want us to find the first term, the common difference, recursive formula, and the explicit formula. All right, let's start with A. Now to do this, we're actually going to do a trick that we did up here, but we're actually going to do it twice. So I know what the 8th term is. I know the 8th term is 75, so I can say 75 is... I don't know what the first term is. I'm going to leave that as my unknown. I do know this is the 8th term, so 8 minus 1 becomes 7. The problem is I don't know what the common difference is either. I have two unknowns. Now I'm going to write a second equation. I do know the 20th term. The 20th term is 39. Once again, I don't know the first term. I know this number is 19, right? 20 minus 1. And once again, I do not know the common difference. Mathematically, this is called a linear system. We learned how to solve these in college algebra. I'm going to use the substitution method. So I'm going to take this top equation, and I'm going to get a sub 1 by itself. Move the 7d to the other side. And then I'm going to take this and I'm going to substitute it into the second example. So my second equation becomes 39 equals, I'm going to substitute that in, 75 minus 70d plus 19d. Subtract the 75 from both sides, right? So 39 minus 75. Negative 36. Combine these two numbers. 12 and divide by 12. So my common difference is negative 3. I'm subtracting 3 every time, which makes sense, right? It's going down. Now I'm going to take this and I'm going to plug it into one of my original equations to find my first term. I'll plug it in right there because it's easy. 75 equals a sub 1 plus 7 times negative 3. And this is really easy. Let's see, 75 plus 21. My first term is 96. So I found my first term and my common difference using a kind of little bit of a trick, using a system of equations problem. All right, now we should be able to do the recursive formula. Let's see if we can do it. The recursive formula for this problem, well, we know what a sub 1 is. Remember, you always have to give a sub 1 on the recursive. A sub n equals a sub n minus 1 plus negative 3. That's the recursive formula for this sequence. Part C, what they really want us to find is the explicit. A sub n equals a sub 1 plus n minus 1 times negative 3. And you got to be careful. They're always going to want to make it look pretty. If I distribute the negative 3, I get negative 3n plus 3, or negative 3n plus 99. This is the explicit formula. So on this one problem, we found the first term, we found the common difference, we found the explicit, and we found the recursive formula, all on the same problem. A lot of stuff going on that one. Well, just like in the last section, we still need to be able to find the sum of a sequence. Remember when we take a sequence and add it up, we call that summation. We have to be able to do the same thing. Now, the nice part is there's actually a formula for the sum of an arithmetic sequence. The formula is S sub n equals n divided by 2, a sub 1 plus a sub n. Again, n is the number of the term. A sub 1 is the first term. A sub n is the last term. So again, if I'm going to add up the first blank terms, I'm going to use this one. Let's do an example. Find the sum S sub n of the first n terms of the sequence. All right, so they want us to add this up. Remember, you could add it up by hand. You could write it in summation notation. Now we're adding a new formula. They want us to find S sub n. This is going to be n divided by 2, the first term plus the last term. And again, remember, they're going to want to make it look pretty. Let's see, 8 plus 5 becomes 13. There's the formula for S sub n. Really important to note, this is mathematically the same as this, which is mathematically the same as this. All three of those are the same thing mathematically. They're just different ways to represent the same information. All right, another example. Last one for me, and then you're going to practice on your own in the homework. Find the sum. So they actually want us to find S sub n. There's a problem though. We don't know a lot of stuff. Look, all they're giving us is the sum. All right, so let's see what we can figure out. We don't know what n is because they didn't tell me. I do know what the common difference is. The common difference of this problem is going to be 4. I do know the first term is going to be 60, and I do know the last term is going to be 120. So I'm going to plug in what I know. S sub n, I don't know the number of the terms, but I do know the first term, and I do know the last term. Let's see what I get here. S sub n equals n divided by 2. Let's see. That's 180, so that's easy. Let's see. A little bit tricky here. Oh, I know what I have to do here. Because they didn't give me n, I got to do another trick. Just like on the previous problem, we're going to do another trick. So my trick is I'm going to jump back to the explicit formula. Remember, the explicit formula says a sub n equals a sub 1 plus n minus 1 times d. And so this trick is very similar to the one we did a couple of problems ago. I know the last term is 120. I know the first term is 60. I don't know the number of terms, but I do know the common difference is 4. So you subtract 60 from both sides. Let's see, divide by 4. Let's see, 60 divided by 4, is that 15? Yep. So I know that I have 16 terms in this. So now I can finish my formula. S sub 16 equals 16 over 2 times 180, which equals 8 times 180. Let's see, 8 times 180, 1,440. You don't believe me? Add up all 16 of those. I promise you, you'll get 1,440. So once again, this is an arithmetic sequence and series. The next section will be geometric sequences and series. And hope you're having a good spring break. Bye.